This lesson is on scientific notation, and for those who've never done scientific notation, first of all, it's good to know why we have it. And we have it in science for writing very large or very small numbers in shorthand form. So, to write very large or very small numbers in shorthand form. So this is a very large number. This number is called a mole, and if you wrote it out as a very large number, it would be 602 with 21 zeros. 1, 2, 3, 1, 2, 3, 7 sets. 3, there's 4, there's 5, there's 6, and there's 7. Okay, so we don't want to have to write that big of a number. So we write it like this. So when we write in scientific notation, it's going to be written as two factors. Factors are things that are multiplied together. And that's why we use this time sign. And this is one time when we use the time sign. Very rare, but this is one instance. Okay, so these two factors, this part is the factor that has to be a number greater than or equal to 1 and less than 10. This other factor is going to be a power of 10. And we could write this as a 1 with 23 zeros behind it, but that defeats the purpose because then we have this very large number multiplied by this number. We write it as a base 10, so it's a lot more compact and easy to write, because this means 10 times 10 times 10 times 23 times. And so that's like a 1 with 23 zeros. But when we multiply it times 6.02, we end up with 602 with the 21 zeros behind it. So every time, increasing the exponent in a power of 10 by 1 is the same as multiplying the number by 10. So we want to look at this chart, and to start with the chart, I'm going to start here in the middle. Okay, so if we have this number, which is between 1 and 10, and we multiply it times 10 to the 0 power, well, 10 to the 0 power is 1. We're not going to, this is scientific notation, but this is not a very large number. This is the exact same number. So we wouldn't really use it here, but I want to show you how it incrementally increases by 10, a factor of 10 each time. So 10 to the 0, then if we multiply this by 10, we get 10 to the first power, which is just 10. So instead of taking this times 1, now we're taking it times 10. When we multiply anything by 10, it's like moving the decimal point one place value over. So when we move it over 1, it becomes 23.45, or 23 and 45 hundredths. So if we multiply it by one more power of 10, then it becomes 10 to the second power, which is the same thing as 10 times 10, or 100. And when we multiply by 100, we move the decimal point over 2 places to the right. I hope I didn't say left up here. To the right. And so now we have 234 and 5/10. So if we go one more factor of 10 up, then we'll have 1,000, which is 10 to the third. We move the decimal point 3 places to the right. So that's going to become 2345, 2,345. We've moved the decimal point 1 place, 2 places, 3 places. Notice we have an exponent of 3. Move it 2 places, exponent of 2. Move it one place, exponent of 1, because this is 10, 100, 1,000. So as we move down this chart, and they get bigger by powers of 10, it moves one place to the right. What moves one place to the right? The decimal point moves one place to the right, which increases by a power of 10. Okay, so now let's move up, and let's start at 10 to the 0 again. So as we move up, if we have 10 to the negative 1, that's the same thing as the reciprocal of 10 to the negative 1, which would be 1 over 10 to the first power, or 1/10. And 1/10, when you multiply something by 1/10, that's like dividing by 10. So that would be like moving the decimal point to the left one. So that's shown right here. So that makes it 0.2345, or 2,345 10,000ths. So then if we move it, or we divide by another power of 10, that would be like multiplying by 1/10 again, and 1/10 times 1/10 will be 1/100th. So it's like 1 over 10 squared, which is 1 over 100. So it'd be like dividing this number by 100. So if we move the decimal point over 2 places, we'd have to add 1 0, and it becomes 2,345 100,000ths. So then if we divide one more 10, that's going to be 1 over 10 cubed, which is the same thing as 1/1000th, which would be like dividing this by 1,000, so that would be moving the decimal point back 1, 2, 3. So if we move it back 3 spaces, that means there's going to be 2 place values. We have to put in zeros, the 2, and then 3, 4, 5. So again, it was moved to the left 1, to the left 2, to the left 3, and notice I'm 10 to the negative 3. So over here, as we move up this chart, it moves one place value, the decimal point moves one place value to the left. The numbers are getting smaller with each decreasing power of 10. So with that, we're ready then to look at how would you change this and write it in standard form, write the big number out. Well, if we're going to take 1.35 this time, times 10 to the 5th, notice that's a number between 1 and 10. We're going to move the decimal point 5 places because it's like multiplying times a 1 with 5 zeros, or 10,000. So 5 zeros means we're going to move it 5 places. So as we move to the left, the 3 and the 5 count as 2 of those places, and then 3 more, which means we'll tack on 3 zeros. So it'll be 135, 0, 0, 0. To check that, if the decimal point is here, we're going to move it to the right 5 places, 4, 5. So that works. So it's 135,000. This one, now we're moving to the left because that's really 1 over 10 to the 3rd power, which is like dividing it by 1/1000, or dividing it by 1,000, multiplying by 1/1000. So we're going to move to the left 3 places. So 1 will take up the 2, and then 2 more. So it'll be 0.0027. So that is moved from here back 1, 2, 3, and it's 10 to the negative 3. So the number gets smaller. So for 10 to the negative 4, we're moving it back 4 spaces. So 1 and then 3 zeros. So that's going to be 0.000201. The next example, we're going to write this in scientific notation. So it's a very small number. So we have to figure out what number, the 2 factors. One of them is going to be a number between 1 and 10. It could be equal to 1, but it's not. So if we move this decimal point back between the 7 and the 0, 7.09 is less than 10, but greater than 1, times, now we have to figure out what exponent of 10 would we have to have multiplied this 7.09 to get 0.00709 back again. So that means we have, if we move it 3 to the right to get it here, then we'd have to move it 3 to the left to get it back to this again. So that would be 10 to the negative 3. Example 5, we have a pencil. It's 18.7 centimeters long. And if you were to lay 10,000 of these pencils out from end to end, they want to know how many millimeters would that be. So we want to write the answer in scientific notation. So if we're going to lay this out, 10,000 pencils,